All right, our next speaker is Dale Kolstad, and he's going to be talking about a remote legacy mine in northern Canada, and the Pine Point mine is a Cominco facility. He's originally from Iowa and in Minnesota, correct? And I'm originally from Minnesota. We think of Iowa as an extension of southern Minnesota. But anyway, Dale Cole says he's a senior environmental engineer and a vice president of Barr Engineering Company. Dale has over 20 years of experience in the civil and environmental engineering field. He assists mining clients across the Americas with tailings management, waste and water projects, contaminated site remediation, and reclamation and closure projects. Welcome.
All right, good morning, and thank you for having me. Really enjoyed the conference so far, so nice job and congrats to the organizers. Thank you for putting this on, and careful what happens. So I came last year for the first time and was chatting with Susie and Steve, and they said, hey, where are you from? Where do you work? What's going on? So as you were mentioning, teased out a nice, paper saying, hey, we'd like to hear from a site, north of us as well. So here to talk about water, which is on the theme of the conference here as well. And then I have to say, we have about a handful of Montana Tech grads, and they're great people. We also have some Montana and some Montana State grads. And now those folks seem to want to quarrel with each other a little bit. So there must be some rift there that I'm not aware of. But anyway, learning more. All right, so here's the topic of my presentation. I'm not going to read it because it's such a mouthful. The short answer is I'm going to talk about how a water balance is used to make good operational decisions on a closed mine site. That's still in active care. Okay, so my pitch to you, any of you folks who have to manage one of these legacy sites, especially when you have a portfolio of sites, you have a lot of planning and scheduling to do. My pitch is every site that has a potential dam safety or water quality concern should have a calibrated probabilistic water balance model. If built right and used right, can be very helpful because water management, as we've heard for the last 2.5 days, is a common challenge at mine sites. And these high water levels, especially in mine features like tailings basins, as we've heard about, can lead to those physical and chemical instability concerns. So both physical safety, human health aspects, and then also the environmental protection components. So informed decision making, that's where tools like this can be really helpful because the quality of your decisions are always going to be based on the quality of your input. And so that's what really drove the development for the model for this site. And a lot of sites, and we've come across this in many of the legacy sites we've managed, have simple spreadsheets that can be functional for many purposes, but they're often very simplified, right? They have a lot of high level assumptions, again, which can be okay for their purpose, but not necessarily for making operational decisions. Okay, so I'm going to share with you a multi-year case study here. It's actually, a very live project, and we're learning on the go. So lessons learned sharing is a big part of what we do, and in an effort to continuously improve and do better with these things. I'll talk to you quickly about the site. I'll give you some background and context on why water management's important here. The model was originally built for a different purpose. We were doing long-term closure and reclamation planning updates. And so we were gathering data for that purpose and developing it for the purpose of really quantifying inflows and outflows and the mass loading so that we could figure out which reclamation scenarios would be most appropriate. Then we ended up repurposing it for short-term decision making because the facility was being challenged by higher water levels recently. And I'm gonna spend most of my time talking about where the value of the tool lies here. Okay. So we'll take you straight north up to just south of Great Slave Lake. If anybody's been up to the Northwest Territories, you're just getting close to those northern lights. It's very beautiful up there. Very surreal. It's a boreal forest area. Very pleasant if you want some more quiet place and a spot to hide from Californians. No offense to any Californians who've made it here. Anyway, so the site it's huge. It's about 900 hectares, or about 3.5 square miles. So it's very big. They mined about 70 million tons of material. 10 million tons went off as concentrate, and about 60 million tons ended up in the tailings basin here. There's a gravel cover on top of the tailings because dusting was a real issue at the facility. They can get some really good winds out there, and obviously it had some nice expanse. But they did not protect it from water contact. At the time of closure, they believed that as the process water. See, I spent a lot of time in Canada. As the process water flushed out, as they thought the process water flushed out of the system, that things would clean up pretty well. It's a neutral mine drainage site, so it's a metal leaching site. So it doesn't have the acid component. It's circumneutral, but it does have metals. You can see the dike in the foreground here, and we contain that contact water, and then that's treated annually and discharged. So it's a rinse and repeat type of situation here. And this has been going on since the mine operated from '64 to 1988. And those are kind of the big pertinent details. So why a probabilistic water balance model? As I mentioned, it's really, we wanted to look at those long-term closure scenarios. And so we spent about 3 years doing a reclamation research program to get the right data to parameterize the model. I'm not gonna bore you with the gory details there, but the really important aspects were, obviously you needed the tailings physical and chemical characteristics. We needed to quantify the flows, the water levels. We put a research grade MET station on the facility too, because we were between some regional stations, and so we wanted to get some site specific data, especially on evaporation. And then we did use the Goldsim platform. How many people are familiar with the Goldsim platform and water balance modeling? Okay, just a couple of folks. But it's a really nice modular tool. And what's great about it is you can kind of start simple and build out with complexity there. And so what we did is infographic here that you see on your right is the site. It's been turned now, so you can see the pond is on the far right edge with the dam that contains that contact water. And I'll just touch on a few of the kind of the bigger and more important features. There's a lot of components in the model, but one is the stochastic climate module, and so that was built on about a 75-year climate history from the regional stations that we could build. And we did include the effects of climate change too, so for the forward forecasting. And luckily there's been some great work out of the University of Alaska Fairbanks, and we were able to use their representative concentration pathways, or RCPs, for those folks who are familiar with that type of work, and apply those. And in this region, basically it's going to get warmer and it's going to get wetter, but it's going to actually change from us being more of a snow-driven system to maybe a little bit more of a rain-driven system. So there'll be some changes in the forecast for us to consider in the long-term planning. We broke the pile, even though it's huge. We were able to just break it into 2 sections to handle, a coarse tailings section and a fine tailings section. And again, we wanted to start simple and add complexity as needed to represent actual site conditions. That's, in my opinion, a very important part of model development. And so we could have broken it into lots of sections, but two seem to work just fine for this effort. I want to focus on the natural area run-in, which you can kind of see there with the green that says east drainage. That's an interesting area. So the dike got finished about 3.5 sides. So because they stopped prematurely due to the economic downturn. And so the dike didn't fully encircle the tailings facility. So we have this interplay with some natural run-in. There's a big diversion channel on the far eastern side, kind of near that mine haul, kind of halfway between that mine haul road you see there in the pile. And that's been a subject of kind of ongoing operation and monitoring as well. And then there is some interplay with the regional groundwater as well, because it's a pretty shallow water table scenario, and so we're interfacing with that. We're not the geotechnical engineer of record for the facility, so we're on the closure and reclamation planning side, but they're in the process of reviewing the TARP and updating some of these levels. But at the time, so this is last year's 2021 freshet. We had some of these key levels, and I just want to reference these so that you know what they mean as we go forward on the value side. But that bottom green line, the culvert invert to the polishing pond, that one's just basically as far as they can draw it down with gravity flow from the facility each year as they're treating water. Usually it's just above that from a practical standpoint. You can see the stage storage curve comes up and it really starts to flatten out there as you get above about, maybe 500,000 cubes of water. I should mention the facility, on kind of a drier year might get around 700,000 cubes, and on a wet year might be closer to 1.5 million cubes. So you can see we're kind of in that play between, right, the culvert and the spillway every year. And so there's these alert levels at 2016, and then the 2019 is kind of the big one. That one for our client is a big deal. You go above 2019, they have to have continuous site presence. They need to have people there. They have to have resources ready to start drawing down the pond if they need to. And then obviously as it runs up towards 2025, pose the risk of a spill. And again, I was talking to my kids about this the other day, and they were like, well, why is this important? And I said, because if you're an operator and you got handfuls of sites, and every spring you need to be thinking about those and dealing with those, knowing ahead and scheduling resources is not a trivial matter. And so that's something that I really gained appreciation of. What we were dealing with here is they were having some trouble in the previous year with some water treatment, and then they got some late fall rains, which kind of recharged the pond. And so we were sitting in a bit of a precarious position. And so the questions came, hey, freshet's coming next year or next spring. Here's some questions we have. Will the pond level rise to a level that is unsafe for the dike? Will emergency response actions be required due to unsafe pond levels? How long will staff expect to be on site this year? What resources will be needed? So these questions all came out, and this is where we use the tool to help our client make some of these informed decisions. So this graph is showing the probability of not exceeding, which I always think is a little bit of an interesting term, but my water resource engineer, Corey, he says, this is the way you do it. I'm like, okay. So not exceeding, I still look for the 50% mark so that I can ground myself. But basically in the fall of 2020, we started with a projection, and we had a range of about 2 meters of water level bounce, which you saw on that stage storage curve is huge, because there's just so much uncertainty at that time, right, in terms of what's going to happen. And then what happened is we continued to monitor the snow development at the site, and then obviously as the season got shorter, you're able to refine your prediction. And at this time, so this was in December 2020 or early January, maybe 2021, we about halved that range to about 1.1 meters, but still a pretty significant bounce there. And so, but at the time, this is early planning, so start of the year was, hey, are we going to have a spill? Yeah, 1 in 10. Are we going to need to be on site? Yeah, 9 out of 10. So that's kind of, that early level, where are we going to be at? And this is a freshet-driven system. So the snowpack development is a big deal. And you saw the size of the site. A lot of runoff. It's coming. So if the snow is there, they're going to get a lot of water. The curve on the left there shows the predicted maximum snow water equivalent. Again, the snow water equivalent, so how much water, not how much snow, is actually in the snowpack. And the range there was about 10 to 29 centimeters, which is a big range. And this was done right at the end of 2020 again. And so we're looking at that piece, and then and that sensitivity. And on the right there is the scatter plot of 100 random simulations, looking at those ranges of predicted snowpack and the corresponding pond level. And the scatter comes from when does the snow arrive and how fast does it run off, and some other factors like that. So there's several variables here that can come into play, hence the benefit of the stochastic component. As we move closer to freshet, we really tighten the range up as you venture, right? Because you're running out of season, and you have a lot of knowledge about what your snowpack is on site. We had people go out do snow surveys, which is probably the most important information on site, because any of you folks who deal with cold weather know that your snow at one station, maybe 100 miles away can look very different than your snow at your site. So being able to go out and actually quantify how much snow was on the ground was really important. And you can see here the band really tightened. So now we got about a half meter, range. And, a little bit of comfort came with, hey, the chance to spill is now really, really low. But hey, we're gonna have a lot of water in the pond, and we're gonna need to be on site, right? It's nearly certain we're gonna need to be on site. So let's start planning for those, early drawdown operations. And so then the next question was, well, when do we need to be there, right? So again, the benefit here, and this is gonna follow the same theme. When we first started, we're like, 6 to 7 weeks is kind of your window. That doesn't help planners very well. But then as you get, kind of early on, as we got closer, so about 2 months out here in early March, we said, well, that window looks like it's about 3 weeks. And then when they really wanted to start getting prepared to go, which is about a month ahead of time, we said, yeah, we think you're going to be, within, 3 days or so of May 12th. And they said, great. Now we can start getting that on pencil. We can get our operators moved over here because they're on a different site. And so we need to get them here. And then, with the benefit of the 14-day weather forecast, we were able to narrow that down to within a day. And so the client arrived a few days before that, saw the pond level come up and exceed the tarp when they were there. And they have a lot of confidence now in the model, but we're testing that as we go here. So beyond then the freshet planning piece, and they did not have any dam instability issues. They did have to go out and monitor it according to their tarp, but the water level bounced to where we thought it was going to be, and things behaved pretty well. Then they pivoted to, okay, now we got to draw the pond down. We need to do treatment. And so they got out on site and they were treating. This graph shows the water surface elevation on the primary axis and the discharge rate from the treatment facility on the right axis. The blue line is the water level. The little stars were actually actual measurements from the pond. So the blue was the modeled value from kind of mid-June there. And then the black line is their discharge. So they took a little bit of time to get up and running at full speed and make sure the system's all working very well. And they said, hey, so here's where we're at early August. And they said, when are we going to be done? So that last star was when they kind of called us there in early August. And we said, well, we kind of know your trajectory for your discharge rate. We have the climate piece built in. We have a pretty good sense, from operational experience, what window you might end up in. And they said, good, because we need to demobilize this crew and start winterizing gear. And they said, hey, if we end soon enough, can we do some extended treatment and drawdown to try to avoid being in this situation in the future? And we said, yes, you can. And so we kind of gave them that window from the climate perspective. They do struggle when it gets colder and windier in the fall with the treatment system. So it was kind of a nice, helpful add for them to plan the tail end of their program. So I'm going to fast forward to this year. Which is still happening right now. Corey, who is my co-author here, actually flew home yesterday from the site. So this year was a little bit more interesting. So this is similar to what you saw before. This is snowpack development. So this is the the snow water equivalent by date here. And you can see that we're kind of building up. And we're kind of trending towards the middle there. And you see that actual 30 millimeter event that happened kind of in late March there. And that kind of bounced us up into about the middle of the pack. So we're trending kind of towards the drier range. And so that was feeling really good. It might be a real kind of a low key year. But then we had to bounce up to about the middle. And then we got forecasted with another 30 millimeter event. And so I realize I'm speaking in metric terms. So I added this the other day. So that's about 1 inch of water, or 10 inches of fresh snow. And again, big area. So a little bit of snow goes a long way. And so that was going to bounce us up towards the upper range. And so the implications were significant. And again, this was in the forecast. It hadn't actually occurred yet. And so if you remember our probability curve from before, we had those kind of lighter two blue bands from early on. That was where we were predicting the water level in the pond. And then with that, inducing this forecasted event, we jumped all the way above the 2019. Kind of changes the whole disposition again. We were on standby. We were feeling pretty good. Oh boy, we might be in a situation where we got to be back on site again. And then hey, weather forecasters, not as good as water balance forecasters. Storm missed the site. But it's actually really interesting for these shorter term forecasting, and a site that's as sensitive as this to weather it's a big deal for us to be diligently paying attention and actually truthing what happens out there. And so we basically went from the dark blue back to the yellow and then eventually to the orange for this year. So it was like a kind of a bit of a momentary panic, but we said, hey, if the storm doesn't happen, we'll be in a different situation, or if it's worse, we'll be in a different situation. So hence we had to watch that pretty close. And then associated with that, I mentioned the east drainage area, and that with a diversion channel along the side, part of the questions, or some of the questions then that got posed were, well, when's that really going to flow? And we'd like to get out there and see this thing operating. We have some concern about how well it captures run-in. And again, it's a pretty remote site. It takes about a day to get there. And so you're trying to plan ahead for this. So we got our 14-day weather trend that we imposed on the model. You can see kind of that first peak there, daytime high of about 14 degrees Celsius. So we were expecting some water to move when we were doing this modeling exercise. And then we had a little bit of a drop down, and things were going to cool off for a little bit, and then they were going to pop back up. And kind of the rule of thumb for this site, and I think in several spots I've been at, is when you have a couple of overnight lows above zero, and your daytime highs are obviously well above zero, you're getting a lot of water moving. And so we were looking at that kind of that first week of May for a lot of activity. And so the model predictions were, obviously you see that first spike, and that was that first warming day. So a fair bit of water moving because it was so warm. And a lot of sunshine. And then you can see we predicted a kind of a big peak there between the 3rd and the 7th. And that's why Corey went to the site so that he could go stream gauge and see the water. So we were able to plan our resources. Client was able to plan their resources. Happy to announce that they were there at the right time and saw that. So that was pretty great. We're also testing some new features with the model. One is ice cover development. And this one's important for us just because there's some water quality changes too. So there's the ice thickness here on the y-axis, and time obviously on the x, and kind of the grayish, or sorry, the red line is the modeled value for the water level, or sorry, for the ice thickness, and then the bluish colored lines are kind of the thicker, or the maximum, the minimum, and the average thickness. So you can see we kind of nailed it there. We ended up with about, 70 or 80 centimeters of ice. And then the gray line is actually one of the key metals that we track at the site, its concentration and how that was influenced by exclusion from ice and a pH shift and solubility controls on the pond as well. I won't get into that, but it's part of the importance for us tracking all the loads as well. So it concentrates up underneath the ice. And then we have water quality equipment in the pond. We have zones that sit out there over the winter to collect that real-time information as well. And so it's important for us to know when's the ice coming off. And so the blue line there is the ice thickness, and you could say we predicted it to be off on May 11th, and that didn't happen. So 1 for 2 on the ice piece here. That little dip I showed you actually was much more significant than the dip that was forecasted. And so things started to freeze back up, because you can imagine the water was just about freezing. So it didn't take much, and things kind of locked up again. And then they're opening up again right now. So kind of really sensitive to those minor weather changes. So this is just a view of the treatment facility, kind of looking back towards the pile. And I think what I wanted to say is that, this model has been really useful for this short-term operation and monitoring planning. We didn't envision it to be used that way when we first started, but it's kind of nice. Once you have a model built, you can make it really functional. Actually, one of the client reps said, hey, we build a lot of these models. It's nice to see one being used so successfully. So that felt really good. And if you have sites that are similar to this, it's worth thinking about, because you can build one and use one pretty quickly. So thank you for your time, and I think I have a few minutes for questions.
Any questions?
You said you have the UAF data, or, estimates for
Yeah.
climate change. What sort of anticipatory events or volumes of water are you expecting to see at the site into the future? How far out are you looking?
Yeah, that's a great question. I think surprisingly on this site, it's on a net, it's not very sensitive to it because, like I mentioned, temperature and temperature increase and precipitation increase, but the precipitation is going to transition more into rainfall than snow, and we don't have big rainfall runoff behavior here because it's at coarse gravel cover, and so it has a hard time running off real hard. So it's on a net, the water balance doesn't seem to be changing too much, but the intensities are changing and that sort of stuff. We looked at RCP values. I'm sure I'm going to screw it up, but I think between 4.5 and 8. So, and I think 6 being in kind of the middle range there.
Any other questions, please?
I wanted to know, was there ever a time that scheduled treatment maybe went off balance and caused any issues at all?
The question was when scheduled treatment went off schedule or off balance?
Or something to that effect that would have caused any issues?
Yeah, this is a low density sludge operation. You can see it was a serpentine channel, and so they slurry lime and inject it, and it makes a low density sludge. We had a speaker the other day from Wood talking about the transition to their HDS plant from an LDS plant. So those LDS facilities, yeah, they're more prone to upsets, and especially like this because it's not a tanked system. So you're dealing with that serpentine channel to provide the hydraulic residence time for the precipitated metals to fall out. And so yeah, depending on what concentration is fed into the system and what the pH is, they actually have a pH limit on the backside of 9.5. And so those of you with redox chemistry background, that sort of stuff, with the pH like I said, zinc is one of the primary ones. There's a lead zinc mine. So you're kind of flirting with increasing the pH high enough to form all those precipitates and to get them falling out, but at the same time not running the pH so high that you would be challenged on the effluent. And so we're actually helping them with optimizing that system a little bit more. So yeah, it can be a little fickle in both the dosing and pH range. And then also I mentioned the sensitivity at the end of season. So if they're working late in season when the water level's low, they can stir up that sludge bed too, and they just have less time for those particles to fall out. So yeah, it's taken a little bit of work, but they had a record last year. They treated over 1 million cubes. So when it's running well, it's running well. So,
Thank you.
yeah.
Any plans for revegetating that site?
Yeah, that's a great question. They didn't strip organics.
No.
Oh, I know. So when I first showed up, I went, where's the big pile of dirt that I get to work with? And there's no big pile of dirt. It's a bit of a blessing, though, I have to admit, because that organic layer is pretty active underneath the facility, too. So the groundwater piece is attenuated pretty quickly, which is, like I said, fortuitous. But the bad part is, yeah, it's very slow natural succession there. We are absolutely looking at ways to accelerate revegetation, find some ways to consolidate the pile. It's so big, so we're going to need to get creative on how we start to develop, some of these microsites, how we start to bring in woody and organic materials, how we're going to get the right nutrients. It's nutrient deficient. There's a reason why it's still so barren. We have one of the community members said, that plant would grow on the moon. So when we point at some of the vegetation that started, but we got a couple of, pines that have started, and there's a couple areas where that holds moisture a little bit better, and organics have started to accumulate. So there's some hope that we can find some ways to improve the site as we move forward.
Any other questions? Right here. Please come up to the mic.
So I'm curious about your tarp.
Yeah.
Did you use this model to develop your tarp levels, or did it kind of inform the risk tolerance?
It is. That's a great question. So I don't know if you missed the beginning part. I'm not the geotechnical engineer of record for the facility. And so I'm not developing the TARP. The model is being used by our client in the geotechnical engineer of record to inform their decision making. They had used a different surface water runoff model to develop the TARP. And so they're trying to mesh that a bit because there's, as you know, there's certain layers of conservancy that are built in there. They're trying to see what's a reasonable precipitation event. That reliance on a practical matter, the diversion channel is huge. If that thing's not functioning, the site's flooding and they're at risk. Whereas, and so, you know, and as you're looking at a TARP, you're assuming some of these things fail. And so our client's very diligent about maintaining that channel, making sure that it's functioning appropriately. So I don't know if I quite, it's moving in that way. So, and they have a independent tailings review board too. We heard about that the other day. And they're commenting too on what would be the appropriate way to use the model in that regard. So yeah, great question.
Okay, thank you, Dale. Susie, we got some door prizes?